Scientists said Europa was leaking its ocean straight into space. In 2013, Hubble caught faint signs of water vapor escaping the icy moon. For over a decade, it stood as one of the best cases we had for sampling alien life without ever landing on the moon. Then, in 2026, a team went back through 14 years of data. The signal was a 2-pixel mapping error. 99.9% confidence dropped to under 90. So what actually happened to Europa's water? Okay, so let's go back to 2013. Lorenz Roth, an astronomer who's now at KTH Royal Institute of Technology in Sweden, is looking through old Hubble Space Telescope data of Europa. That's the icy moon of Jupiter, the one everybody gets excited about because it might have a liquid ocean under its shell. And he spots something faint, really faint. Ultraviolet light coming off the moon's south pole, the kind of signal you'd expect if water vapor was escaping into space. Like a geyser, but way bigger and way colder, and happening on another world entirely. And here's the thing, this wasn't just a, neat moment. If Europa really was venting water from its ocean, that changes everything about how you'd study it. You wouldn't need a lander that drills through miles of ice, which, to be clear, nobody currently knows how to build anyway. You could just fly a spacecraft through the plume and taste it, sample an alien ocean without ever touching the surface. That's the dream. Because it held up for a while. The 2013 finding got a lot of attention, and honestly, it made sense with everything else we already knew about Europa. The surface has cracks and ridges that look geologically active. There are magnetic field readings that are still, today, some of the best evidence we have for a subsurface ocean. So a plume wasn't a wild claim sitting on its own. It fit into a picture that was already pretty convincing. But, and this is where it gets interesting, nobody could catch it doing it again. Follow-up Hubble observations, including a fresh look in 2020, just didn't show the same signal. No localized emissions, nothing repeating in the same spot. And when a discovery only shows up once and then goes quiet for years, that's usually the point where scientists start asking harder questions about their own data. This is the part I love, honestly, because it's such a small, almost boring explanation for something that made headlines around the world. A team led by planetary scientist Juan Alday went back through the full dataset and found two problems stacked on top of each other. First one, a positioning error. Europa only takes up a tiny fraction of Hubble's detector. We're talking a 1024 by 1024 pixel grid, and the moon is a small dot inside that. The original analysis placed Europa's position off by 2 pixels horizontally and 1 pixel vertically. That sounds like nothing, right? 2 pixels. But when your signal is a handful of extra photons in the first place, a 2-pixel shift is enough to fake a bright spot that isn't really there. Second problem. Back in 2013, nobody knew Europa had a thin hydrogen exosphere, basically a faint haze of hydrogen atoms floating just above the surface, scattering sunlight. That glow wasn't discovered until years later. And once you know it's there, you realize it was quietly inflating the brightness readings right at the exact spot where the plume appeared to be. 2 small, unglamorous errors. Stack them together and a real discovery turns into a statistical illusion.
Here's where I want to be careful, because this isn't a story about scientists being wrong for no reason. It's a story about science actually doing its job. The team's own numbers say it clearly. Their original confidence in the plume's existence was 99.9%. After the correction, that dropped to under 90%. That's still not zero, it just means it's nowhere near strong enough to call it a confirmed discovery anymore. And it's not like this reanalysis is the lone skeptic in the room either. Back in 2019, a different observatory, SOFIA, an airborne infrared telescope that's since been retired, looked for the specific chemical signature water vapor would leave behind, and found nothing. Then in 2023, the James Webb Space Telescope, which is way more sensitive than Hubble, took its own look and also came up empty. So you've got 3 separate efforts using 3 different instruments, all landing in roughly the same place. Maybe, but not proven. No, and this is the part that's easy to miss if you only read the headline. The ocean itself isn't what got debunked here. It's specifically the escaping water, the plume, that fell apart under review. The geology, the cracks in the ice, the magnetic field readings, all of that evidence for a subsurface ocean is completely separate from the plume story, and none of it went anywhere.
Let's actually sit with that evidence for a second because it's stronger than people realize. Back in the 1990s, NASA's Galileo spacecraft flew past Europa and measured something called an induced magnetic field. Basically, Jupiter's own enormous magnetic field was reaching out, touching Europa, and getting bent and reshaped in a very specific way. The kind of way you'd only see if there was a layer of salty, electrically conductive liquid sitting under the ice, acting almost like a shield. Water does that. Solid rock doesn't. That single measurement is still one of the strongest, most independent pieces of evidence for the ocean, and it has nothing to do with plumes or Hubble or ultraviolet light at all. Then there's the surface itself. Europa's ice shell is covered in these wild, chaotic-looking regions, jumbled blocks of ice that look like they've been broken apart and refrozen, plus long, curved cracks that stretch for hundreds of miles in smooth, sweeping arcs. Those arcs match almost exactly what you'd expect from tidal flexing. Europa getting squeezed and stretched as it orbits Jupiter, over and over, which generates enough heat to keep an ocean liquid underneath a shell of ice. So between the magnetic signature and the surface geology, you've got two completely independent lines of evidence, collected by two completely different missions, decades apart, pointing at the same conclusion. Europa almost certainly still has a giant liquid ocean under its ice shell. We just lost our best evidence that any of it was leaking out where we could easily sample it. This is where it stops being a story about a mistake and starts being a story about what's coming next. NASA's Europa Clipper is already on its way, and it's set to arrive in the Jupiter system in 2030. Once it's there, it'll fly close enough, often enough, that if Europa really is venting water, even occasionally, even faintly, Clipper should be able to catch it directly, instead of squinting at 2 pixels on a photo taken millions of miles away. Until then, this one stays open. Not confirmed, not ruled out, just unproven, in the most scientifically honest sense of the word. And if you ask me, that's a more interesting place to leave it than a tidy yes or no. If you're into stories like this, where the universe almost hands us the answer and then takes it back, consider subscribing. It helps me keep making videos like this one.